Here's one more for fun here. Look at this one. The sine squared of 3x times cosine 3x dx. I mean, you know, this is pretty complicated. You can't stare at this and just come up with an antiderivative. And I mean, you need to get it into a form. So I think you need U-substitution, and I guess if you want to help me, you could try to tell me what you think U ought to be.
3x.
Okay, that's good. Now, you know what? You're kind of right, although you're kind of right, but you're kind of wrong. I mean, that goes with the theme of what I've taught you so far today. I mean, you fell right into my trap. Right, the U should be the 3x. I mean, that's what it's been so far today. But that, well, you want to see something? Okay, watch this. You aren't ready? Watch this. If you do let the U be 3x, okay, help me out. What's the du?
Du is 3 dx.
It's the derivative. So it's a 3 dx. It's this new way of doing a derivative, you guys. You take the derivative of U, you call it du. You take the derivative over here, you call it a 3 dx. You need that. It's the du dx relationship. So when I start to replace all this stuff, I'm gonna go ahead and move the 1/3 over here just so you see it nice and clear. When I replace all this stuff, it's sine squared of U, right? Times the cosine of U. And then what's the dx out there? 1/3 du. If you don't mind, I'll pull the 1/3 out front and put the du there. So good, we accomplished that U substitution. Very good, y'all, we did good. Now the problem is I still can't integrate this unless I do another U substitution. So I need another U substitution. Can you see somebody? Remember, it's the inside. You know, U tends to be the inside thing. That's why y'all said 3x. The 3x was inside those trig functions. And it sort of helped me, but it ain't the whole. I need more. Do you see another inside dude?
Can you rewrite the sine squared 3x and then do it? Like make it sine of 3x squared?
Well, that's what it is. Thank you. I mean, when I write sine squared of 3x, we all know what I mean. I mean the sine of 3x squared. So whether I write it like that or not, your brain, we need to think like that, right? Whether I write it like that or not, we need to think like that. That is what's going on. And so maybe you're saying that's the inside thing? See, look, you guys already made me do a U substitution, so I'm not redoing it. Here I am. I went from X's into U's. And now I'm suggesting I need another U substitution. So I'm going to use another letter, and I'm going to do another U substitution. I'm going to call it W. So what do you think W should be? The sine of U, right. I was trying to get to the inside guy. The sine function is being squared. The sine function is inside the squaring. I think I should let W equal the sine of U. See, what helps too is if I think of the derivative. See, whenever you decide you want to let U or W be something, think ahead. Think about the derivative. What's the derivative of sine?
Cosine.
Well, ain't that cool?
Yeah.
See, I needed that. Damn it. Cosine of U du. The derivative is the cosine of U du. I'm happy. You're supposed to be happy. Don't look as happy as I am.
Okay, so
Because when I replace this now, I'm replacing all this crap. Here I go. What's going on? The 1/3 is out front. What is this?
W squared.
W squared, he says. That's my W squared.
and that
And what is that?
DW.
DW.
Okay.
So I've converted this problem into a new variable, W.
Yeah.
And by the way, now that it's staring, I mean, you do this change of variable process until you get to a form you can integrate. Can you integrate something squared? Yes, it's something cubed over 3. It's W cubed over 3. There's also another 3 out there. The answer to this is W cubed over 3 with another 3 out there, 1/3 out there, plus C. There's the answer.
So it's 1/9
Which is 1/9 W cubed. All right, hold on. That's the answer. But wait a minute. We got to take our W's and turn them back into U's.
and then turn it back into X's.
So if I turn it back into U's, this is sine cubed of U.
Sine cube of U.
You guys okay?
And now we gotta turn it back into X.
Oh, and now I got to turn my U's back into X's. Right. What were my U's?
Okay.
3x.
So
Okay.
it'd be sine U over 3x plus 2.
There's the answer.
Oh, wow. Is that the only way?
I guess I needed double U substitution. Oh, get it? Double U substitution.
Okay.
I needed double. I didn't really need W substitution. I didn't need, but you guys asked me to do this, so I went with it. But that required a second substitution, as you can see. You could have avoided that if you would have went with the correct or a more efficient beginning substitution, which would have been, do you know what it would have been?
Sine 3x.
Yeah, good. The sine of 3x. If you just would have called it that, you could have went straight from x's into u's. Right.
Okay.
Let's just, I don't know, let's just try it. What's du? What's the derivative of this?
Cosine.
3x. Isn't it 3 cosine of 3?
And hang on. So if I call this u, now I want the derivative. What's the derivative of sine 3x? Good. It's cosine 3x. The chain rule spits out a 3
Okay.
dx. And when I get a derivative, I got to do a little chain rule on this one.
Okay, so this right here.
And so now, hold on.
So 1/3.
I'm going back straight to this. Here we go. Here we go. What's that sine squared 3? Oh, that's my u squared. Sine. And then what's that cosine 3x dx? What is that cosine 3x dx? That is,
1/3 du.
yeah, I need to move it's a 1/3 du. You're right. You guys see it? Good. You're learning, dude. This is good. So here I am. Now, how do you integrate a u squared? U cubed over 3 times 1/3, if you don't mind.
Right? So see, and then put back your
You guys are good. This is 1/9, and then I got this u cubed. And what was my u? This guy. So we got the same place. Is that the same answer? That's the same answer.
See if with their function within the function.
Here's another one. Try this. This is kind of easy, maybe. Except, well, yeah. Yeah, this is good. This is perfectly fine. Can I shut up and make you work? It's going to be a challenge. I'll tell you, the only way for me to shut up and make you work is if you got to tell me what to do. You work yourself, but you can just, I'm just like a robot that stands up here and you tell me what to do. If you don't tell me what to do, I'll do weird shit.
And you're gonna draw right here, and then draw right here.
Well, you could pull out
I don't
too.
think that's gonna work.
Yeah, I could. I don't want to. So you're looking for a U, and you're looking maybe for something inside something. Maybe you're not seeing the inside on this one. Maybe that's a problem. But
But, yeah,
See,
it comes
again-
out weird.
U.
So let's call it x squared plus.
see, whatever you call u, think ahead to the derivative. That helps a lot. You gotta, it isn't,
Okay, U equals 2.
so whatever you think u should be, think about what the derivative of that is and how it, that,
I think it's gotta be the x squared plus.
yeah, that helped, right. So if you think about the derivative of what you're gonna call u, it might help you decide what u is. I mean, and I know there's no inside except that you could call that denominator kind of, anyway, I think the denominator should be u. She saw it because then you know what she was thinking? If she just saying, well, maybe the denominator should be u. So immediately she thought of du. What's du? The derivative, 2x. And then that kind of, when you look over there, that's 2x. I mean, maybe this makes sense, right?
Yeah, yeah.
If this is my u, then du is a 2x dx. 2x dx, you know, by the way, when this dx sits off to the side, it's definitely off to the side or in the numerator. It's not in the denominator. That's where this dx is. So to me, there's a 2x dx right there. So that is, I'm calling that du. What about my denominator? My denominator is a u. Are you guys with me?
Yeah.
I called something u. I found du, and it was beautiful and perfect, and everything just fell into place beautifully on this one. So now all I got to do is integrate a 1 over u du, and that means I have to recall how to integrate a 1 over u du.
ln of u.
It's the ln of u.
Plus 6, and then
Yeah.
substitute.
So it's the ln of u. Technically, we put absolute value when we integrate this. Oh, technically we put absolute value, but now let's put our x's back in. What was u? X squared plus 1. Watch me, now I'm going to lose my absolute value.
Yes, because it'll never be negative.
Just because this quantity x squared plus 1 is never negative.
Yep.
It's a variable squared plus another number. It's never negative, so it's not wrong to put absolute value, but it's redundant. You don't really need it. See, you know, again, well, now in 5.5 you do this u substitution, and I'm going to be honest with you. You know what? You won't have any of these. This is this with u in the denominator and du in the numerator like that. The answer to this is a log. And for some reason, they save all these log problems for 5.7. So in 5.7, they kind of save all the log problems. I don't know why. I'm not sure why. Maybe they just didn't want to mix too much together at once. So in 5.5, there's a lot of u substitutions, but there won't be log problems. And then you get to 5.7, and there's more u substitutions like this involving log. So that's cool. A lot of stuff involving log up in 5.7. So I took a little leap ahead there, I guess. You know, so you guys, I guess, I don't know, we're searching for rules. What are our rules? I don't know. I mean, if you have a u to the n, we got that rule, don't we? That's u to the n plus 1 over it, right? That's called a power rule, right? We got that rule. Do we have a rule for cosine of u du? Yeah, that's called the sine of u, right, you guys? I could do a couple more, couple of these trig ones, but what else do we got? We got e to the u. What's the rule for e to the u? How do you integrate an e to the u?
E to the U.
E to the u, right. What else we got? We got 1 over u. Well, how do you integrate a 1 over u? ln of u, right. I mean, there really isn't that many. I mean, there's more trig stuff I could write down. But there's that. There's those two guys. And then there's 5 or 6 trig functions, right? I mean, there isn't too many other things. There isn't. I mean, I don't know. There isn't too many things you can integrate. There isn't too many rules we know. You know, again, here's a weird one, but secant squared of u, that's something we should know. That's tangent, right? I mean, so there's a few oddball things out there, but I mean, trig stuff that we're supposed to know. Anyway, so a lot of the stuff I was working on today was power rules. I mean, they ended up being power rules. They looked like a mess, but when we did the U-substitution, they ended up as a power rule of U. But then I did I did a cosine U's, and I did some e to the U's, and now I just did a 1 over U. So it could be other things, but there isn't really infinite options. It's finite number of options here, patterns that we're looking for.
I have a question.
Sure.
Alright, you integrated 1 over u, right? Let's say if that was a 2 over u, is it possible to integrate it as ln u's or c?
Yeah, you pull the 2 out. That's the whole concept of pulling these constants out. A 2 over u is really just a 1 over u. Pull the 2 out.
What if it's a negative number? Is it
Pull it out.
It'd be ln u, either way.
With a negative, right. So if you put a -3 up here, you pull the -3 out,
Okay.
it's 1 over u, and the answer has a -3 in front of it.
Oh,
I mean, when I say you pull it out, you just pull it out so you can see the pattern,
gotcha.
but it's there, it's multiplied in front, so it's multiplied in front of your answer. Right, if you had a 7 e to the u, a multiplied 7, you pull it out, but you put it back, it's right, it's just on the answer. Right.
Okay.
Right, so multiplied constants never bug me. I mean, I pull them out and you know, this was a 1 over u du. This was ln. Here, let me show you another one here. Watch this one. Are you ready? Here's one. What do you think u should be on this one?
X squared plus 1.
I mean, good. I mean, I hope, right, there shouldn't be too much debate anymore. I don't know, we could debate it but he said it. Do you agree? I mean, it's inside the square root, it's down in the denominator, but yeah, I think the u should be what's inside the square root, x squared plus 1, especially when my brain starts thinking about du. du is 2x dx, and I know the 2 doesn't jive with the 5, but the x is there, you know what I mean? I mean, so the du is 2x dx, and I am so happy to see that x dx. That's going to help me get rid of that x dx there, right? And the fact that the 2 and the 5 don't jive doesn't bother me. Those are constants that I can pull out in front of the integral. You've been seeing me do it all day. Here we go. If I replace this integral now, I think the denominator is a square root of u. I think the 5 should come out front. And I think that circled x dx is basically 1/2 du is what that x dx gets replaced with. So I replace it with a 1/2 du. When I do that, I put the 1/2 out front because I like to do it like that. So now I'm staring at this problem. Can you help me? I mean, so again, hopefully you get the game. The game is U-substitution, and then after you do the U-substitution, you end up with an integral that you can do. I mean, or that's in a form that you can do, or it's almost in a form you can do. What would you do now? What would you do now? You don't know what to do with this square root of u. You don't know what to do with this square root of u, huh?
To the negative 1/2.
Negative power.
Yeah, you make it a power rule. You do a power rule. That's it. You do a power rule. Sorry. I mean, look, there ain't too many options, like I said, right? And now it's in the denominator. Watch out, though. To be a log, you have to be a u in the denominator, not a square root of u. That ain't a log. And not a cube root of u, and not a u squared, and not a u cubed. You know, just because it's in the denominator doesn't make it a log. To be a log, it's got to be a 1 over u, and then it's a natural log. You with me? So this is a square root of u. That's just a power rule. You're right. You move it up. You call this 5/2 out front. You move it up and call it u to the negative 1/2. Now, have you integrated? Have I integrated? No, I just moved it up. I manipulated and did some algebra and moved it up, and now I'll integrate. Okay, I'll do a power rule. Okay, I'll add 1 to it. Adding 1 to it is
Half
u to the 1/2.
over
You're
half.
supposed to divide by 1/2. But when I divide by 1/2, I just assume multiply by 2. So I'm multiplying by 2. Don't forget, there's a 5/2 out here, and plus c, and we're done. Well,
Cancel,
we're done integrating. I should clean it up and put the right answer there.
cancel.
Did you catch that, though? Move it up, do a power rule.
Yep.
That's not a log. Let's move it up, do a power rule. Cool. The 2's cancel. You get 5 times the square root of
X squared plus 1.
x squared plus 1 plus some c out there. Yeah, man, we're integrating today, man. We're up in 5/5. We're doing this U-substitution technique. Opens up a whole bunch of integrals that you could never do before. You got to fight through the U-substitution to do it. I'm gonna quit today.